Imagine you've built this like absolutely gorgeous Java application. You're running it on your local machine, and it is just lightning fast.
Oh, yeah, everything's green.
Right. The code is clean, all your tests pass, everything feels perfectly engineered. But then, you deploy it to production, real users start flooding in, the data grows, and suddenly your app just slows to a crawl.
Or worse, it completely crashes with an out-of-memory error.
The classic "it worked on my machine" nightmare. I mean, it's a scenario that plays out in tech companies literally every single day.
It really is. And it's so frustrating because more often than not, the culprit isn't your core business logic.
Right, your algorithms are usually fine.
Exactly. The real issue is these silent killers hiding in how your application actually talks to the database. And that brings us to our mission for this deep dive.
Yeah, we're digging into some really crucial stuff today. We really are. We're looking at this fantastic compilation of sources, insights from Thorpe and Jansen, intense Reddit discussions from developers who are just, in the trenches. It's all synthesized into this guide called Mastering Java, JPA, and Hibernate, Best Practices and Pitfalls.
And it's so needed because these tools like JPA and Hibernate, they are incredibly powerful. I mean, they save us from writing thousands of lines of boilerplate soup.
Absolutely.
But they hide massive complexity beneath the surface. If you don't understand what the engine is actually doing with your data, you are going to get run over by it.
So true. The goal today is to transform you, the listener, from a potential victim of these silent killers into, like, an absolute master of database performance. We are uncovering the traps that catch everyone from juniors right up to seasoned tech leads. Okay, let's unpack this. Before we can fix the cracks in the house, we really have to understand the difference between the architectural blueprint and, well, the construction crew actually building it.
That is a vital distinction. A lot of developers, they use the terms JPA and Hibernate interchangeably, but they are fundamentally different concepts.
Right.
JPA, the Java Persistence API, it is not a runnable piece of software. It's not a library that executes tasks on its own.
Wait, so when I use annotations like an entity or a table in my Java code, I'm not actually running any database commands.
No, not at all.
I'm just tagging my code with rules for object relational mapping.
Precisely. You're literally just laying out the rules. You need a separate entity to read those rules, interpret them, and then write the underlying SQL to talk to the database. And that is where Hibernate comes in.
Okay.
Hibernate is the actual framework. It's the designated provider that implements the JPA spec and does all the heavy lifting.
Okay, let me refine that house analogy then. So JPA is the architectural blueprint. It just says, hey, there should be a door here and a window there.
Exactly.
But Hibernate is the actual construction crew that shows up with the hammers and the wood to build the house based on that blueprint.
I like that visualization. And to add one more layer to it, I mean, most developers today are using Spring Data JPA, right?
Definitely.
So you can think of Spring Data JPA as the project manager. It sits on top, gives you easy tools, relies on the JPA blueprint for the structure, and then by default, it hires the Hibernate construction crew to do the actual building.
Okay, but wait. If JPA is just a standard blueprint and Hibernate is this specific crew, what happens if I start using Hibernate's exclusive power tools to build my app faster?
Well, that's where it gets tricky.
Right, like say I have them use proprietary materials that only this specific crew knows how to install, like Hibernate's custom cache or their specific query language. Doesn't that mean I can never fire them? Like I'm permanently locked into using this specific crew.
You've hit on a critical trade-off there. If you stick purely to the JPA standard, the basic blueprint your application remains completely flexible. You could, in theory, fire the Hibernate crew tomorrow and hire a different provider, like Eclipse Sync.
Oh, wow. Without changing the core code.
Exactly, without changing your core code. But the moment you use a Hibernate-specific feature, you accept vendor lock-in. And understanding this is crucial because when you hit a bug, you have to know if you're violating a structural rule from the JPA blueprint or if your Hibernate crew is just executing the instructions poorly.
That makes total sense.
Yeah.
So now that we know who is building our application, let's look at the catastrophic instruction developers accidentally give this crew. I want to move to the stuff that actually brings servers down. The silent performance killers.
Oh, boy. Yeah.
The most famous one in the source material has to be the N+1 queries problem.
The absolute bane of ORM performance. I mean, it is responsible for so many sluggish applications.
Let's walk through how this usually happens, right? A developer writes code to get a list of, let's say, 50 orders from the database.
Simple enough.
Right. Hibernate fires one SQL query to get those orders. So far, so good. But then the code loops through those orders to print out the customer name for each one.
Yep, and here it comes.
Exactly. Because of how the objects are linked, Hibernate suddenly fires a brand new, separate SQL query to fetch the customer for the first order, then another query for the second, and so on. So you end up with one query for the list plus 50 queries for the customers, n plus 1.
And scale that up, you know?
Yeah.
If you have 10,000 orders on a dashboard, you just fired 10,001 queries at your database in a single second.
Oh, man.
Your network bandwidth just gets completely choked by all those tiny individual requests.
It sounds like ordering a massive pizza for a party and then making the delivery driver go back to the restaurant separately for every single slice.
That is a perfect way to put it.
But why would the system ever default to doing it the slow way?
What's fascinating here is that ORMs prioritize object-oriented convenience over SQL efficiency. They're designed to let you navigate your Java objects smoothly, moving from an order to a customer as if they were just sitting right there in memory.
Right, it wants to pretend the database isn't even there.
Exactly. The framework doesn't know in advance that you plan to loop through thousands of them. It just fetches what you ask for, the moment you ask for it. So the fix is, you have to tell Hibernate your intentions up front.
How do you do that?
You use a join fetch in your query or an @ entity graph. This forces the system to grab all the orders and all the related customers in one single massive SQL select statement.
Okay, so one trip to the restaurant for the whole pizza. Got it. But reading through the sources, it seems like trying to solve that can lead developers into a completely opposite trap. Abusing eager fetch types.
Oh, a very common overcorrection, yeah. When you define a relationship in JPA, like a many-to-one, say, many employees belong to one department. JPA defaults that relationship to fetchType.eager.
Meaning, every single time you query an employee, Hibernate will just automatically join the department table and fetch that data too.
Yeah, every single time.
Even if I just wanted a simple list of employee names for it, like a drop-down menu, I'm dragging all this useless department data across the network, wasting memory for absolutely no reason.
Which is exactly why best practice dictates you should almost always override that default. You need to set all your relationships to fetchType.lazy.
Okay, L-A-Z-Y.
Yeah. Lazy loading means Hibernate replaces the department object with a temporary placeholder, known as a proxy. It's essentially a hollow shell. Hibernate only fires the query to fill that shell with actual data if you explicitly call .getDepartment in your code later on.
Okay, hollow shells, that makes sense. But the sources highlight an incredibly insidious trap when developers combine these lazy proxies with a library called Lombok.
Oh, the Lombok trap. Yes.
For those listening who might not use it, Lombok is this wildly popular library that auto-generates boilerplate code. It has this annotation called @data. You just slap @data at the top of your entity class, and it writes all your getters, setters, and your equals and hash code methods behind the scenes.
And that is exactly where the trap springs.
Really?
Yeah. When Lombok generates the hash code method for you, it uses all the fields in your class, including your collections of related entities.
Hold on, I want to make sure I understand the mechanics of this. Why does generating a hash code cause a database problem?
Well, think about what happens when you take an entity and drop it into a Java hash set. The hash set immediately calls the hash code method to calculate a mathematical value, right? So it knows where to store the object in memory.
Right.
To calculate that math, Lombok's generated method tries to read the fields inside your lazy loaded collection. It literally knocks on that hollow proxy shell we just talked about.
Ah. And because Java is demanding to read the actual data inside the shell to do the math, Hibernate wakes up and says, oh, you need this data. Let me go query the database to fill the shell.
You've got it. Just by putting a Java object into a Java set, you silently trigger a database query.
That is wild.
And it gets worse. If two entities reference each other and you throw one into a set, calling hash code can cause an infinite circular reference loop where they just keep waking each other up until your application crashes. Yeah, the solution is to avoid @data on JPA entities entirely. Be deliberate. Use @getter and @setter, and write your own equals and hash code methods using a unique business key. Never the relational collections.
Be deliberate. That's a really great takeaway. Another area where developers aren't deliberate is fetching data without limits. The guide calls this the find-all trap.
Missing pagination, a classic mistake.
Yeah, a developer sees a table with like a few hundred records in their local dev environment, so they just use repository.findAll to get them as a list. It works beautifully.
Until it doesn't.
Right. The code goes to production, the app gets successful, and that table hits 2 million records.
And when you call find all on 2 million records, Hibernate attempts to instantiate 2 million full-weight Java objects simultaneously, and it tries to shove them all into the application's heap memory.
Which obviously won't fit.
Right. The server simply cannot hold that much data at once, and the application just instantly dies with a fatal out-of-memory error.
So what's the fix there?
For large data sets, you have to use pageable in Spring Data JPA. Instead of returning a list, you return a page or a slice, processing the data in safe chunks, say 50 records at a time.
All right, so let's take stocks for a second. We've optimized the queries, we aren't choking the network, and our app isn't crashing from memory overload.
Looking good so far.
But, making an application fast doesn't mean much if a developer tries to optimize a deletion and accidentally wipes out the entire database. Let's look at data safety, specifically how Hibernate manages the life cycles of relationships.
This is where things get really delicate. We need to talk about cascade operations.
Oy.
Cascades define how actions performed on a parent entity spread down to its children. For instance, cascade type.rRemove. If you have a quiz entity and it has a list of question entities, they have a strict parent-child relationship.
Right, a question can't really exist without its quiz.
Exactly. If you delete the quiz, you want JPA to automatically cascade that action and delete all the questions associated with it.
The child dies with the parent. But the sources highlight a stronger, slightly scarier mechanism called orphan removal, where you set orphan removal true. What is the fundamental difference between the two?
Let's use the quiz and questions again. If you only have cascade type.remove and you take a question and remove it from the quizzes list in your Java code, nothing happens in the database.
Wait, really?
Really. That question just becomes a wanderer in your database tables. It has a null parent ID, it's taking up space, but it still exists. It's basically an orphan.
But if I enable orphan removal,
If orphan removal is on, Hibernate actively monitors the list. The moment it sees you remove a child from the parent's collection, it realizes the child has been disowned. It automatically fires a delete SQL statement to permanently wipe that child from the database.
that is incredibly powerful. But here is where I get genuinely alarmed on behalf of anyone listening right now. What happens if a developer applies these cascade deletes to shared relationships, like a @manytomany or a @manytune?
Oh, this is the nightmare scenario.
Right. Say I have a user entity and it has a relationship to an admin role entity. If I accidentally put cascade remove on that relationship and I just delete one single user who happens to be an admin, does that wipe out the entire concept of an admin role from the global system for everyone?
It absolutely does.
Oh my God.
It acts as a global self-destruct button. And unfortunately, it's a button that gets pressed by accident quite often in complex code bases. You must explicitly understand the difference between strict ownership and shared reference.
Okay, break that down for me.
Sure. An order line item is strictly owned by an order, but a user does not own the admin role. They merely reference it. You should only ever use cascade remove or orphan removal on strict @onetomany or @one-ton parent-child relationships. Never apply them to shared references.
Never to shared references. Okay, deep breath. We've survived N+1 queries and we haven't deleted the production database.
Always a good day when you don't drop production.
Right. Avoiding disaster makes you a competent developer. But the source material transitions into a specific senior developer mindset. It's about mastering the engine's subtle quirks. Let's start with a trap that combines two things we already talked about: join and fetch H and pagination.
Ah, yes, the infamous warning code. HH 9000003004.
Yes, you think you're being so smart. You use join and fetch H to avoid the N+1 problem, and you pass in a pageable object to avoid the out-of-memory error. You run the code, it works perfectly, but hidden deep in the logs is that specific warning. What is actually happening under the hood there?
What's happening is a massive silent failure of your pagination strategy. When you join fetch a collection, you are asking the relational database to combine a parent table with a child table. And this creates a Cartesian product in SQL.
Wait, Cartesian product, let's break that down. You mean where the database multiplies the parent rows by the child rows?
Exactly that. Imagine you have one order with 5 items. When you join them, the database doesn't return a hierarchical object. It returns a flat table with 5 rows. The order information is duplicated 5 times, once for each item.
Oh, I see.
Yeah, and because of this structural duplication, Hibernate cannot safely use the database's native limit and offset commands to paginate. If you asked for a limit of 2, the database would just cut off the last 3 items of that single order. Your data would be totally corrupted.
I see. The SQL limit command is completely blind to our Java objects.
Yeah.
So how does Hibernate handle it if it can't use the native SQL limits?
It secretly pulls the entire unfiltered result set from the database into your server's RAM and then does the pagination in memory.
You're kidding.
Nope. If
Oh.
that query matches 1,000,000 rows, it is pulling 1,000,000 rows into RAM before filtering it down to the 50 you actually asked for.
That is absolutely terrifying. It completely defeats the entire purpose of pagination. How does a senior developer fix this?
A senior developer breaks the process into 2 distinct steps. First, they run a query to just paginate the parent IDs, no joins, so the SQL limit works perfectly. Then, they run a second query using that small list of IDs to fetch the data with the collections.
Okay, so it requires knowing when the ORM abstraction breaks down
Huh.
and stepping in to take manual control.
Exactly.
Which brings us to another area where abstractions cause severe trouble. Open Session in View, or OSIV. Here's where it gets really interesting.
Oh, the great OSIV debate.
Yeah, for anyone using Spring Boot, OSIV is a property called spring.jpa.openInView, and it is set to true by default. Its entire purpose is to be helpful. It keeps your database session open during the entire web request, even while your web view or JSON response is rendering, just in case you accidentally trigger a lazy load at the last second. It saves you from getting a crash.
But a senior developer looks at that default setting with absolute dread.
Why, though? If it stops the app from throwing a lazy loading error, it sounds helpful. Why is it considered a massive anti-pattern?
Because of how it interacts with your database connection pool, usually managed by a tool like HicarCP, your application only has a limited number of physical connections to the database. Let's say you have a pool of 50 connections.
Okay.
If OVC is on, your application checks out a database connection the very millisecond a web request starts, and it holds it until the request is completely finished. Now imagine a Black Friday scenario. Your application receives a request, does some database work, but then it needs to call a slow third-party shipping API.
Oh, wow. And let's say that API takes like 3 seconds to respond before it returns the web page to the user. So my thread is just sitting there waiting for 3 seconds, holding onto that precious database connection and doing absolutely nothing with it.
Yes. And under heavy load, all 50 of your connections get checked out and held hostage by threads waiting on external things. The connection pool exhausts, new user requests come in, they can't get a connection, and the entire system locks up and crashes with the connection timeout.
That is brutal.
It is. This is why seniors always set spring.jpa.openInView false in production. They force themselves to handle lazy loading explicitly within the service layer, where transactions are kept as short as possible.
So seniors turn off OSIV to protect the connections? What about writing data? The sources mentioned developers have this bad habit of pulling an entity, changing a value, and then explicitly calling repository.saveandflush to push it back.
Yeah, overusing save and flush actually defeats one of Hibernate's best optimization features, right behind isolation.
How does that work?
Well, when you pull an entity inside a transaction, it enters a managed state. Hibernate takes a silent snapshot of its original state. As you change values in your Java code, Hibernate doesn't need you to tell it to save. It uses a mechanism called dirty checking.
Okay, dirty check.
Right. Right before the transaction naturally ends and commits, Hibernate compares the current state of the entity to that original snapshot. If it's dirty, meaning any field changed, Hibernate automatically generates and executes the optimal update SQL statement.
So by calling flush manually, a developer is forcing Hibernate to push the SQL to the database right that second. That ruins the framework's ability to batch multiple updates together efficiently at the end of the transaction. You just have to, trust the framework to do its job.
Precisely. Let the transaction manage the flush.
But on the flip side, what if we were just reading data? What if we don't plan to change anything at all?
Oh, if you are just reading data to display it on a screen, you shouldn't be using entities at all.
Ah, DTO projections. This stood out in the notes as such a pro move.
It really is.
If your database table has 50 columns, but your front-end screen only needs the ID and the name, don't fetch the whole entity. When you fetch a full entity, Hibernate has to build the complex object, store it in the persistence context, and take that snapshot for dirty checking we just talked about. It takes up a massive amount of memory.
Right. So instead, you create a simple data transfer object, a DTO. It's just a basic Java class with an id and a name field. In your Spring Data repository, you write a custom query that selects just those 2 columns directly into your DTO constructor.
Nice.
Because it's not an entity, Hibernate skips the snapshotting, skips the dirty checking, and generates a hyper-optimized SQL query. It speeds up read operations immensely and drastically reduces RAM usage.
Which brings us to the golden rule of this entire deep dive, the one practice that ties all of this together. If you want to master JPA in Hibernate, you must turn on SQL logging and statistics in your development environment.
If we connect this to the bigger picture, this practice defines what a true senior developer is in this space. A senior skill isn't just knowing the Java syntax.
Right.
It's the ability to look at a block of Java code and mentally simulate exactly how many SQL statements will run, how long database connections will be held, and how much RAM will be consumed. You simply cannot develop that intuition unless you actually watch the raw SQL being generated under the hood while you build the application.
Let's recap our journey today. We started by understanding that JPA is just the blueprint and Hibernate is the construction crew. We learned how to survive the performance killers, explicitly telling our crew what to fetch to avoid N+1 queries, turning off eager loading to save bandwidth, and being very careful with lombox at data auto-generating hash codes that accidentally trigger database calls.
The silent assassins.
Exactly. We navigated the dangerous waters of cascades and orphans, learning to never put a self-destruct button on a shared relationship. And finally, we looked at the system through the eyes of a senior, bypassing the Cartesian product trap with smart pagination, protecting our connection pools by turning off OCA, and utilizing dirty checking and DTOs.
It really comes down to respecting the abstraction without being blinded by it. These tools are beautifully designed to bridge the gap between object-oriented programming and relational databases, but they do not erase the fundamental laws of how databases physically work.
And that leaves me with a final lingering thought for you to chew on. The entire reason we use ORMs like Hibernate in the first place is for convenience, so we don't have to manually write raw SQL queries by hand. But to actually master Hibernate, to make it perform well at scale, we just learned that you have to turn on SQL logging, reverse engineer what the ORM is doing, and essentially visualize the raw SQL in your head anyway. So here's the question. Does the convenience of an ORM eventually become a heavier cognitive burden than just writing the database queries by hand from the start?
That is a brilliant question, and it is a debate currently tearing the Java community apart. It's exactly why we are seeing a massive rise in simpler, more direct tools like JOQ or MyBatis. Developers are starting to ask if the magic of Hibernate is worth the mental overhead of taming it.
It is definitely something to think about the next time you boot up a new project. And while you're at it, go check your current codebase's OSIV settings today. You might just prevent a Black Friday disaster. Thank you for joining us on this deep dive.